Excellent. Well, thank you very much for coming. I appreciate everybody being in person. It's great to get out. It's been 2 years since I've done this, so hopefully I don't fall completely on my face. But anyway, so again, thank you for coming, and also for the people that are remote, thank you. My name is David Sweet. I'm the Senior Solutions Architect for Hammerspace, and Dan, my partner back there, who is the Regional Sales Manager. We cover the Southeast, Florida included. Anyway, so what is Hammerspace? Hammerspace creates a global file system. So regardless of where your data is, where your users are, how many different data centers you have, we weave the entire company or government agency's data into a single namespace, and then we replicate it very targetedly across the planet so that users get 1 gig, 10 gig type performance to their data regardless of where they are and where the data originated. So how do we do that? This is very hard to do. It's taken the company like 5 years of development to be able to create a global namespace like this. So what we do is we created a global data environment. We ingest all of your company's data regardless of it, if it's on NAS, if it's on SAN, if it's on-prem object, or if it's on S3 or Azure or AWS or Google or whoever. We turn that into like a single namespace, a single map drive, a single NFS mount. And then we present it to all of your users, all of your applications, to Kubernetes, containers, anywhere on the planet, as if they were all in the same building. Like I said, hard stuff to do. So what we've got here is some users at corporate. We've also got some remote users. They're accessing data on NAS1. They're also accessing data possibly on NAS2. They've got a SAN, they've got on-prem object, they've got cloud object. Lots of different silos of storage. They may be in many different locations. Some could be in Tokyo, some could be in Fort Lauderdale, some could be in London. So how do we weave that into a single namespace? So what we do initially is we do what we call assimilation. So data in place assimilation. So we take all of the metadata from all of your different silos of storage, move that into the Hammerspace environment. We then present the file system out through SMB or CIFS, NFS, parallel NFS 4.2, and we also present it out to Kubernetes. This creates a global namespace that spans all of your infrastructure, again, regardless of where it is. So you may have like NAS1 might be a NetApp, NAS2 might be an Isilon. You might have Pure Storage as your SAN. You may have Clouding as your on-prem object, and you could have any of the AWS, Azure, Google as your cloud storage. So once that's created, of course, being a NAS, we give you all the things you're used to: access-based enumeration, antivirus, auditing, compression and dedupe, disaster recovery, encryption. We also, of course, have snapshots, undelete, versioning, worm. But the cool part is we also give you custom metadata. So like if you can take pictures and run them into AWS Rekognition, and it'll come out and say with 99% certainty, it's a dog. With 92% certainty, it's a golden retriever. We can actually take that data and put it back into your metadata. So if you need to send all pictures of dogs to your workforce in London, we can make that happen. And we only replicate the pictures of the dogs. We don't replicate any of the other data. So very, very customizable around the metadata. And then once we move the data in and assimilate the metadata, we can have policies that say, all right, let's, again, NAS1 might have been a NetApp, NAS2 might have been an Isilon. So once that data is assimilated, we can then move data from the on-prem NetApp to your on-prem object store, to your cloud object store, based on policies. So you may have a policy that says any data that hasn't been accessed on my NetApp in the last 30 days, let's move it to the on-prem object store. And then you can have another policy that says when the data in the on-prem object store hasn't been accessed in 60 days, let's move that to AWS or Azure or Google. So that's very customizable. It's on a file granular level. So very, very easy to make the data go where it needs to be. Obviously, the more expensive asset needs to have the more active data. The on-prem or the cloud object store can have the data that hasn't been touched in 3 months, 6 months, 5 years, 10 years, depending. So in the Hammerspace environment, obviously we're a software-defined solution. We have two pieces of our components. We have what we call the Anvil, which is the metadata server, and then we have, and they come in pairs. You have an HA pair, of course. And then we have our data services layer, we call them DSX nodes. And you can have up to 60 of those. So like we said, any cloud, any on-prem storage. And then, like I said earlier, we do work with Kubernetes, both file and block persistent volumes. The Anvils here, you see 2 of those per site, and then up to 60 DSX nodes per site based on how much throughput and IOPS you need at each location. And the minimum footprint is at least 1 DSX node and 2 Anvils. Like I said, up through, we've got gaming companies with petabytes of storage in us that have 15 petabytes across 9 data centers, all working as if they were all in the same data center at the same time. So here's a distributed workforce case. You've got a company in New York. They have a NAS there. They have a Hammerspace environment as well. They assimilate the metadata into New York. Then they bring up an environment in LA. They replicate that metadata to LA. If there are users in LA that need some of the data that was stored in New York's NAS, we can tag that and send that data, only that data, not the entire volume, not the entire share, just the specific data for LA to LA. So they're all working as if, local, gigabit, 10 gigabit speed. Then the same thing with Singapore. We have a Hammerspace environment there as well. We send the metadata there, and then we send the data specific to Singapore. Then we add London, same thing. We send the metadata up there to the Hammerspace environment. The data that's bound just for London gets sent to London. The users can, of course, have local access again, but in this case, London has a NAS as well. So what we do is assimilate the data for the NAS in London. Now the 2 NASs, the one in New York and the one in London, look and feel as if they're just a single namespace. The users don't know if the data is in London. They don't know if it's in New York. And we keep up with all of that. Now that it's been the NAS in London's been assimilated, we then replicate that metadata to the other 3 locations so that everybody looks and feels as if they're sitting right on top of the storage, so to speak. And that's Hammerspace. We'll be back. Yes, sir.